Hi, I'm Jason Frank. In this video, I present my thesis project that I completed in the fall of 2011 as a part of the requirements for a Master's in Computer Science degree at the University of Tennessee. The application is called ImageRecon. It is a database-backed web application that utilizes the Model View Controller architecture. It is used for controlling image reconstruction jobs for the research of Dr. Gregor, who's also at the University of Tennessee. I was responsible for all aspects of building the application from scratch, including researching what tools and frameworks to use, as well as all design and implementation. In this presentation, I'm going to seek to answer these four main questions. I will start with a brief introduction into the context of the research and motivation for building the application, but most of this presentation will deal with discussing the architecture that I used, and the latter half of the presentation deals with a demonstration of the application. So let me begin by providing some context as to the research that Dr. Gregor is involved in. As you can see here, we have a diagram that illustrates what would be used for the data acquisition. That is, to get input projections that will be reconstructed into a volumetric or three-dimensional representation of an object. So, for example, this stapler here, if my stapler is the object here, in this case a cylindrical shaped object, you're shooting neutrons through the object and projecting it onto a plane in the back. So I'm shooting the neutrons through the stapler, projecting it onto a plane. And then I will rotate the object just slightly and then pass neutrons through again onto another projection. And again and again and again, rotating the object slightly each time. So then the goal of the reconstruction then, which you can sort of see here, is to sort of like see inside the object. So what you'll end up with is a series of slices through the stapler in this case, to where you could sort of fly through the object from the top down to fly through the object, if you will, to see the inside. So an MRI is a similar example that would allow you to see, for example, the inside of my arm. So that's what's represented by these images here. So this opens up a lot of uses for other researchers if they can see inside these objects. So now, to accomplish that reconstruction, there are a lot of parameters that must be tried and some other tools that Dr. Gregor likes to use in his workflow. So why do we want to build this application? I've already alluded to it. There are a lot of parameters, and so his workflow basically consisted of hand editing text files to change parameters between different iterations or his attempts at properly reconstructing the projections. He also had some other tools that he used that I'm going to show you, and these of course were all just sort of separate. They were not cohesive. Overall, the process was not user-friendly, and so I desired to make a user-friendly version that incorporated all of that workflow for him. So let's take a look at how I went about building this. The primary design goals, as you can see here, number one was to have an enhanced human-computer interaction to make it much more user-friendly. Secondly, there were certain tools that we wanted to somehow embed or otherwise incorporate into this application. But perhaps most importantly was I wanted to make an extensible architecture. I wanted to move beyond just building an application that met the minimum requirements and then I moved on. I wanted to think more architecturally and just focus on building version 1.0 that had a solid foundation, so that someone who comes along after me can advance everything I've done, just utilizing the architecture that I've built. So first, with the human-computer interaction, I want to reduce human error. So oftentimes you're inputting strings of a path to files, or you're inputting values that maybe they can only be negative or positive. I want to remove that when anywhere possible. Secondly, by making it a database-backed application, I can store records, and that provides ways to have things like favorites or to use a prior iteration or a prior set of parameters as a template towards a next attempt. As for the tools that we wanted to incorporate, first of all, here on the left you'll see this is Fiji or ImageJ. Dr. Gregor uses it oftentimes to sort of preview how maybe certain parameters are going to look and to do some image manipulation. So he wanted to somehow embed that or utilize it. And an idea I came up with was a file explorer. He was using something like WinSCP, pictured here, to constantly pull images over from the server or from the university's main research area over perhaps to his local machine, so that then he could open them in ImageJ or Fiji, things of that nature, and you're all the time checking if certain files are in the right place so that they're ready for that reconstruction job. So I wanted to actually incorporate that into the application. So to go about making an extensible architecture, I wanted to have a normalized database. I wanted to utilize the model view controller architecture. So I researched ways to go about these things. For the model view controller, one constraint I had was that to run on the university's system, it needed to be PHP based. So I researched those frameworks, and I chose PHP as what appears to be a fairly robust framework that hopefully is somewhat on the easier side of learning the framework as well. But what I found was, with these design goals comes certain challenges. Since we have such a large number of parameters, how do we present that to the user, in a user-friendly way that just doesn't overwhelm them? Secondly, anytime you're building a web application, the stateless view there on the browser is always a factor. And thirdly, when I started to look into the details of Cake PHP, I kind of had to start to ask, is this really model view controller that we're talking about here? And if so, where is the observer pattern? So, speaking of the model view controller, let's take a look at this paradigm and make sure we're on the same page. So, a very simple representation could be shown in this way. And let's briefly discuss what each of these three main components, what their roles are and how they interact. So let's start with the view. The view does not care about the validity of the data or how it is stored, but rather it is concerned with representing the data in a visual way, usually, for the user to see. And another side point is you can have multiple views of the same data. Okay? So now when the user wants to make a change to the data from looking at that view, an event would get executed, such as clicking on a button. When that happens, it's the controller's job to interpret that event and decide what that means in terms of changing the data. So when the controller has figured that out, he will make a call to update the data in the model. Now when the model detects that its data has changed, it will notify each view that it has updated data. In response to that, each view then will make a call to the model to get that latest data so that it can have the most up-to-date representation. This last part, the model notifying the view and the view pulling that latest data from the model, is known as the observer pattern. It is typically implemented by using an interface to where the model will publish an interface that any view that wishes to be notified of changes to its data can simply implement. So in that way, a model will usually keep a list of its observers, and then when a change happens, it will iterate through those observers, notifying them about that change. And then, as I said, then the view will call the model, usually with an accessor or get method, to retrieve that latest data. Now, to make all this more concrete, let's take a look at an example. Let me show, this is a Java application, And we have 3 views, all representing right now 20 degrees. And we can click and drag on one of these views, and you can see that all 3 views are updated accordingly. So what's happening is the controller, in this case I'm on the top view, the controller interprets where I am at between 0 and 100 degrees by counting the pixels basically. And as I move it, it has to determine what that means in terms of changes to the actual model's degrees. And so these other views then are observing that change and simply update themselves when that change happens. So from an architectural standpoint, you can see that once you have the interface and the observer fully set up, you can see how it wouldn't be as difficult now to add a 4th view. Simply the new view will subscribe to changes in the model using the published interface, and it will call that get method that the model's already implemented, and it should work fine. So here's where you can start to see the extensibility, the ease of extensibility for the application. So that's one of the reasons that I wanted to utilize that. Now, as we look at this model view controller and now look to apply that to a web application, let me ask you, what do you see as, some of the main challenge that you're going to be faced with? So for me, it was, okay, now we're going to have a client and a server, and so where are these 3 components going to live? A secondary factor is I've alluded to, how's that observer pattern going to work, because you are typically going to have the model on the server, but with a web application, the server is typically not able to make a call out to the client through the browser. So if you start looking into it, oftentimes you'll see that when you apply model view controller to a web application, you sort of oftentimes see that they act like it's pretty much the same, just that you're sending the view over HTTP or through a basic web browser request to the user, and then when they want to affect the application with input, it's forwarded over the web to the controller on the server. Now let's look at Cake.php specifically, and we'll fill in the arrows between the model view and controller on the server. So first of all, let me point out that I think Cake.php in general is a good framework if your application needs to do a lot of database accesses, doing the 4 primary database operations, your create, read, update, and delete operations. So briefly, what's going on here is, let's say that the user is clicking on something that needs to retrieve database information. So when that request comes into the controller will make a call to the model, and it's sort of treated like a black box. From the controller standpoint, he doesn't care about the database. The model will make the call to and from the database to get that data and return it to the controller, who will finally hand it off to the view to be ultimately returned to the user. So unlike the original model view controller that I showed before, now the controller is placed squarely between the model and the view, both on the data input and output. Second of all, here's where I started to wonder, well, where's the observer pattern? And if you look at the Cake.php documentation, you won't find the observer pattern mentioned anywhere. So this took a little shift in my thinking in terms of how to apply it to this type of infrastructure. Moreover, I felt that this type of diagram does not really reflect what's really going on with the application. First of all, it does not take into account the user's interaction with the application while it's there in their browser. And second of all, it doesn't really deal with setting up or finishing rendering the user's view or their graphical user interface. So we need something with a bit more granularity. So we end up with something like this. So here we see that what we really have is a model, view, and controller on both the server as well as on the client. So let's take a brief look at sort of what these pieces look like. As we push in towards the server to its controller, what does some of that code look like? As you can see, basically Cake's controllers are class-based that utilize inheritance and other object-oriented techniques. As we push over to the model here on the server and look at some of its code, basically you can see that it is also class-based using object-oriented techniques. And briefly I will point out that you do see validation rules that live here, as well as something called associations, which is just their way of tying together your different models, and we'll go over that more later. Now as we look at the view here on the server, we see that unlike the other two components, this is not class-based. The simplest case would be something like this, where you have static HTML with embedded dynamic PHP code that is usually going to fill in dynamic values coming from the database, in this case to output a an HTML table. So this view code ultimately needs to get sent over to the client. But more accurately, we still have to set up GUI state, and furthermore, more accurately, its three main file types get sent: the cascading style sheets, which are going to style the HTML code; the JavaScript, which is concerned with behavior, as well as setting up some GUI state; and the HTML that has been rendered, the PHP has been rendered from the server. But all of that still needs to be rendered into the final view that the user sees. If all that goes well, reaches the user and makes a happy user. Now when the user wants to interact with the application while it's there in their browser, the controller code handles that there, and I'm using traditional JavaScript and jQuery to handle that. So in this way, the entire application works together, utilizing model, view, and controller on the server and the client to as I said, interact with the user while it's in the browser and do database operations on the back end. It's interesting to note that once I started to think architecturally like this about the application as a whole, it caused me to start to question some more traditional web development techniques that I had learned, especially things like cascading style sheets. It just felt so static to me. I wanted to use variables, I wanted to nest one class inside of another, things like that. And thinking architecturally like this drove me to research and find CSS preprocessors, such as the LESS preprocessor framework, which I utilized in this project. So now that we have a feel for some of the design factors, let's take a look at some implementation factors. So now returning back to the idea of this image reconstruction job, the main entities that we want to model in the database are these job group, job, and job versions. So to clarify what these entities are, let's look right here in the middle at a job. A job would be a single set of input projections. So for example, oftentimes Dr. Gregor gets a new job from Oak Ridge National Laboratory, and it would be a single set of projections. So like the stapler example that I did before, where you have lots of projections where you're rotating the object and you're accumulating all these projections. With that single set of projections now, he's going to iteratively try to reconstruct those properly, and that's going to take trying out different parameters and things. So here you're showing the one-to-many relationship there, and you could think of a job version sort of like an output, if you will, because ultimately it's to achieve those set of slices that properly reconstruct it. We do have, however, up above the job, a higher level of abstraction we just call job group, and it makes some things easier in terms of database inheritance and file structure mirroring, because he wants to, in the file structure, store jobs and their files and job versions. It just made it easier to also have a higher level of abstraction called job group. So using these main entities now, let's look at how the design of the database uses those. Here's the entity relationship diagram that resulted from the design. And I'll pull up this in MySQL Workbench so we can take a more detailed look. There's kind of the bird's eye view, and let me zoom in now. Okay, so here we can see at the top is the job groups, and then a jobs, and then the job versions. So a couple things to explain here. First of all, when I was taught about databases in terms of normalizing them, at least to third normal form, which is what I did for this design, I was taught that you have no nulls in your database at all. Actually, I know now that this is somewhat controversial. Even in Codd's own later research, he made specific provision for nulls. Nonetheless, many researchers still hold that it is the best way to normalize your database, and it was the approach that I took for this design. So having said that, it explains why some of these things are external to the main entities. They're an external table if they're an optional attribute. So an alternate name for a job group is optional, so it is in an external table. So going down from there, we do have things like a many-to-many relationship between jobs and tags, so you have a join table for that. Going on down, finally we get down to the job versions right here. So the required parameters are in the table, and the other metadata optional are external. And then out here are all of the optional parameters. I'll touch on these in just a second. Another thing I should explain is what these enum tables are. Zoom in a bit more. So, for example, a job version status. So this is an enumerated set of values. I think we have 5 main statuses, I believe, that you want to provide. And with CakePHP's system, they have a convenient way of handling this to where you can provide an input that has a drop-down that has those 5 main options. So Cake knows that you need a status ID right here, but it's going to show the user the names of those. So that's very handy. And rather than use an enumerated data type in MySQL, which is a bit evil, many people consider it, this is a handy way of doing it. First of all, because now if I wanted to add a 6th status, you can simply provide a way to add another row or another tuple to the statuses table rather than dealing with the data definition language of the database. So you get around that. That's one nice thing. MySQL's enumeration type is not actually very good. It doesn't really enforce those enumerated types. There's some other problems with it. So that's why I have these enum tables to deal with that. Lastly, I will point out briefly up here, both in this base table and this base table, I'm utilizing some inheritance so that with a normal job version, I have sort of like this anonymous set of these parameters. But I also want to have a favorites, so you can utilize favorites, and I wanted them separate from the anonymous set so that if a job version gets deleted, you can see right here by the solid line, it's an identifying relation, or a relationship rather. So I know it's hard to see, but when the job version gets deleted, its associated set of anonymous param certs, for example, should also be deleted. So I wanted that separate so that it didn't mess with a favorites. So that was a design choice for that. Okay, so with that database design in place, whoops, come back. Okay. Once you have your database design in place, how does Cake build upon that? Because it is very important to get that database structure correct first. Okay, so one thing it does is there's typically one model for every table in your database. One nice thing, a really nice thing for a Cake-based application is the object relational mapping. This provides ways to interact with the database without really even writing SQL code at all. So for example, the controller, there's just a method called find, and then you pass in a few conditions, but it kind of keeps you in that in that object-oriented code kind of frame of mind. So I'm not shuffling over to the declarative nature that SQL queries are. So that's very nice. Another thing I mentioned, associations tie those models together, similar to how the relationship indicators in the database design work. You also typically have one controller per model, and then you would have usually one view for each controller method that deals with actually serving data to the client. So I can have methods in my controller that don't deal with serving data to the client, and those typically would not have a separate view file associated. Finally, I mentioned incorporating these other tools. So here is specifically what I did. ImageJ or Fiji and a file explorer called LFinder were incorporated into the application. So to start with, what did I do? Here you can see it actually in the application. What did I do for the ImageJ part? So basically, I figured out ways to use it in a web application. It's traditionally a desktop Java application. So first of all, I run it on the server to do some pre-processing of the images. So things like I downsample them, I put them into a stack, which is kind of like putting them as a single unit, and then I compress them from there before sending them over to the client in their browser. To do that, you have to do what's called, you run it headlessly on the server. That's where a graphical application is run on a server that does not have a graphical environment. Once I figured out how to do that, then the other step to doing that pre-processing on the server was to figure out how to interact with it. Again, it's a graphical application, but I want to interact with it programmatically. So I did that by learning the ImageJ macro language. So in utilizing those macros, I'm sort of interacting with it a bit like an API. It doesn't really have an API per se, but I was able to do what I needed to do on that pre-processing with those macros. Finally, once those images get shipped over to the client in their browser, I open them up using ImageJ or Fiji as an applet that runs in their browser, or at least started from the browser more accurately. And all the user has to have is Java on their machine, and then all of the code for ImageJ is from that applet. With the File Explorer, I found one called LFinder. It is an open source Ajax-based application, which is kind of nifty. So one of the things I had to do was to track down some bugs. Like a lot of open source software, it doesn't work perfectly right out of the box. So that was a good experience for me to do. As far as the application, I implemented it as a modal overlay. So I wanted it available from any context in the application. It can pop up, and then when you're done with it, it can go away, and the context that you were in is still intact. That's because it's a very, it's a nice utility kind of tool that you can do a lot of different file operations with, and I wanted it available in any context. So I think you'll find that adding these other tools provided a nice added functionality to the application as a whole. So now that we've gone over the general design and implementation, let us now take a look at a demo of the application. Okay, so this is the main landing page that you'd first see once you log into the application. From this landing page, your primary objectives would be to find a job, to create a new job or job group, or to explore using the File Explorer. So what I'm going to do first is I'm going to walk through creating a new job group from scratch and then a new job to go inside that job group. Okay, so what's going on here is the application is searching the file system. Let me pull in a little File Explorer so you can see. This special directory called job groups right here, inside of there it's going to search for one of these job group directories that has that is not already in the database. So in this case there's 5 here, but 3 of them have not already been added. So this is part of that taking the human error out of the process. It's only going to provide me with options that aren't in there, and as I click, it's going to pre-fill the path to that job group directory for me. Again, take the human error out of it, and it doesn't even let me edit this. It's disabled, but it shows it to me for verification. And let's provide an alternate name. Let's say that, let's go back to the stapler example. So all of the jobs in this job group are going to be about staplers. So this is handy when, oftentimes a job or a job group coming from, say, Oak Ridge National Laboratory comes from their sort of naming scheme, but it might be a really long, unintelligible, unmeaningful name, and so I like to provide added metadata that enhances your ability to later come back and recognize what you're working on, things of that nature. Alright, so we will submit. Alright, it went well, so the tables in the database saved correctly. I'll also note that the saves to the database are wrapped in a transaction. So when you were looking at the design, oftentimes you'll save from, say, a job and a job version on outward to all those outer tables wrapped into transactions. So if anything goes wrong in any of those saves, all will be rolled back. Okay, so now we have our test group, and we're going to add a new job to it. Okay, again, it's going to take some human error out of the equation. And first of all, let me note that before we even start adding a multitude of parameters, I want to ensure that the user has fulfilled some preconditions, things like copying your input data into the right directory and things of that nature. So if you haven't done that, I'm not even going to let you submit at this point. And it's telling you, of course, go ahead and select your job group and then your job directory. So let's take a look again within the test directory. You can see I've got 2 jobs. Now from this screen we're actually given 3 choices, and these are job groups that have a job inside them that's not already been added to the database. In this case we're going to choose the tests option, and it finds both directories because neither one of them have been added. Now as I select one of these, all the other options are going to be revealed, and actually it barely fits on my screen here, but you can see that the other metadata for a job is shown, as well as a separate accordion tab for the job version, the first job version for this job. Okay, so this first job is going to be about my ultra heavy duty stapler here, so I'm going to give it heavy duty stapler as an alternate name, and I'm going to say that it's the chrome and black bad boy stapler on Jason's desk. Let's give it some tags of office equipment and tests. Okay, so at this point, let's go ahead and add the first job version, which is our attempt at getting the proper image reconstruction parameters. Okay, so here's where the challenge of presenting a large multitude of parameters comes into play. I chose to divide them up into sections or panels, and they're sort of like tabs across the bottom here. And as I click over to the other panels, you'll see that I implemented this motion type of changing of the panels. I wanted a visual representation that these panels or these sets of parameters were related to each other and that they were visually sort of connected in that way. So let's go ahead and fill out, I'll say just the defaults, but extra Roy-Z, one of the parameters we'll come to. I'll take credit for this one. And so this comment area is a nice way that I wanted to provide sort of a note-taking area for it to say why you think it's going to work or why the previous iteration did or did not work. I'll say I think the strange gamma spikes would benefit, can't spell here, from extra Roy-Z. Something like that. Okay, as we select the job type now, here's where we start to realize the model view controller issues on the client and on the server here. So for example, as you see, when it first pulls up, the job type has not been chosen, right? But what if I go ahead and select one? Now that job type panel, if you will, is revealed. But what if this job does not validate? What if it, I submit this and it goes over to the server, but it doesn't validate? You have to return this entire, all of this structure back to the client here to fix something. But now you start to deal with GUI or graphical user interface state, right? When I first pulled up, it was there, but the user shouldn't have to start over on these things, right? So now you get into dealing with sending some state information back from the server to the client to be recreated, to finish rendering that GUI state. So we'll take a quick peek. Again, most of these are filled in with default values. Here's another state issue. Like you can see, I've selected that. So you've got both the values of the fields. So if this doesn't validate, you need to return all of the values that I gave you and remember this state so that you can recreate that. Okay, now to illustrate the validation factor, let's go ahead and let's purposely give it some invalid values on a couple of these panels. Okay, and before we submit, I will point out that this mechanism here is for submitting the job to do the processing on the CUDA parallel processing cluster that the university owns. So this is an entirely different processing mechanism, I guess, than what I explained earlier, but it's a set of computers that interact as a single unit to process the images much faster than a single machine could. Okay, so let's go ahead and submit and we'll see what happens. Oh no, it didn't validate. Alright, so here's one of the challenges. I've I've wrapped up all of these parameters in these accordions and these tabs and all this. So now the challenge is, if it didn't validate, how do I quickly show the user where the mistakes were, since things are sort of all wrapped up inside of each other? So I implemented sort of a breadcrumb strategy. So of these two main accordion tabs, you can see the red X on the job version. And then once we're there, we see red X's on 3 more panels, and we know that those are where our errors are. Alright, so we'll go ahead and fix these errors. And then we will submit the job from there. Okay, so we have several messages here. This is because when you submit this job version, a number of things need to happen. Of course, all of those parameters need to be saved to the database, but you also need something called a configuration file saved. This is for Dr. Gregor's C code. His C code needs a text file of all of these parameters, sort of in his own little format. I call it Gregor++. But it's what his code needs. I'm getting a warning here that an executable file was not found somewhere where my control script expects it to be. I can fix that later. But another thing that needs to happen is a CUDA control script. This is a shell script that needs to be provided to the CUDA cluster that kind of tells it where my input files and things of that nature are. And there's several things on the file system that you need to create to house the reconstructed images and things of that nature. And I am getting an error here that says it could not actually submit it to the CUDA cluster. That's because I'm not actually connected to the school system right now. And actually, I should point out that I'm actually running this on a local server, local to this machine right now. The university's server is having some issues right now. The staff is working on it, but it's making it very slow. And so for this presentation, I wanted something quicker. So I'm not actually going to be able to submit to the CUDA cluster. Okay, and now we see we are taken to a view of the newly created job, as well as the first job version. As I pull in the file system view again, we'll see that now we have this job-1, which corresponds to the first job version. And you can see the configuration file, a control script was generated, a reconstruction output directory. There's no images in there because I'm not connected to the CUDA cluster at the moment. But now as I hover over this first job version, I get some more options. Okay, so I can check out all of the details that I just worked with. I can launch. That's strange. Where's my tooltip? It's not showing up. Normally a tooltip would tell you that that's going to let you view some output images. I can edit or delete, of course. But at this point, we start to get into the iterative nature of reconstruction in terms of, with that single set of input, iteratively trying to achieve the proper output reconstruction. So what we're going to do is, we could either just do another default version, but this is where it starts to get handy with the database-backed record system. We're going to use this first one as sort of a template. So it's going to pull all those values from the database. Now, unlike before, the job itself now is held constant. You can see those metadata values are there, but we're only adding a new job version for it. And now we'll say Dr. Gregor's taken over. And he'll say Jason's parameters did not work at all. And we'll make another attempt at it, and we'll change the entire type to FDK, and we'll keep the rest of the parameters as they are. And again, you see the GUI state, since it was a copy of the other one, this area was shown and the values were retrieved. and we'll submit that. Okay, and the same types of things have happened. So now you can start to see how eventually you'll probably end up with a whole list of job versions here until you achieve the desired outcome. Okay, so at this point, instead of me pulling in an actual operating system file explorer, let's start to utilize the built-in file explorer called LFinder. So as I click on the Explore button, I'll be presented with the modal overlay, and let me just briefly show some interesting capabilities that this provides. As I go over to just some test images, you'll see that I can select an image and get a nice preview of it. It is resizable, it is draggable, or I could double click on it and actually get a full-size output in a new browser window. You can do all of the normal file system type things like create directories. I can copy and paste. Actually, I think I can do a Control-C and then go in here and Control-V. Yeah, so you can use keyboard shortcuts, things like that. That's what I did here. Or to do it graphically, I could drag and drop, things like that. Other handy things, though, are, and I should back up and point out that this is, again, this is looking at files that are on the server. So this is not looking at local files here. This is like going through your browser, sort of going over to the server and pulling up a file explorer on the server. So these are this is an Ajax-based system that's giving you a view of what's on the server. And when I copy and paste and make a directory, it would be like me, driving to campus right now and going on the actual server and creating that new directory or copy and pasting this actual file. So that's what's very handy about it. Another interesting thing you can do is you can make a new file. Once I've made it, I can edit it. So that would be like me going to the command line on the server and typing vim and making a new text document. So this is what I was talking about, about how it's a nice utility tool. Gives you just some ways to do some ad hoc checking or moving some files, making sure that the control script is what I thought it was, making sure the web app did its job. As I look now at the job groups and we look at here in the tests, this is the one we've just been working with. Let me change this to a list view. So here you see job-1, job-2. That corresponds to the first two job versions. You can see proj data. So this is actually the input projections. I just have a very small set for this example. If we go into job-1, we can take a look. Here's the config file that Dr. Gregor's code needs. I could edit that. You can see these are sort of parameters in the format he's expecting. I could just go in and add a note. So it's very handy. So I will use this from now on in the demonstration to sort of show what's going on behind the scenes. Okay, so let's introduce the other major tool, the image manipulation program ImageJ or Fiji. First of all, we'll do it from the perspective of wanting to look at input data. So I go back to this Create New Job Version screen. And here we find it. It's going to be available from any panel here. So I implemented this using Ajax request. So as I click on it, and now my tooltips are finally coming up, you can see that I'm going to look at projections from the input data. And what I'm going to do is click on this and without refreshing the page, make a call back to the server and say, make those image stacks that I talked about. This is where it's going to downsample it, put them in a stack, compress it, and then ship it over to my browser here. Open it up, and it's an applet, so it just requires Java, and then open those stacks for me. So I'll show you why those stacks are handy. So when I click on this, I'm actually disabling the user interface at this point so that you don't keep clicking over and over and over, because it's making those image stacks on the server. You can see things are opening up. I've got some nice messages that explain what's going on. And I'll pull this down. So this is the applet version of ImageJ. You can see has opened. And here are the stacks. Let me make them smaller so you can see them. There's 3 different types of images that he primarily deals with. That's why there's 3 separate stacks here. One of them is the main projections, one of them is the dark stack, and one of them is a blank or an open beam. And he uses these for different purposes, but to illustrate why these stacks are handy, here you can see as I scroll through these on the bottom, you actually can't really see a difference. They're so dark, but so they just need lightened up, right? I can adjust them, go right here, click auto, and what it's done is it's made that change not only to the first image in the stack, but it's propagated it all through to all the other images. And I know that may be hard to see, but these are the very slight change because, again, we're rotating an object just slightly with each new projection. So that's why it's handy to have this stack. It's sort of like a single unit, if you will. You can also see that the original dimensions were 2048 by 2048, but that the version that is shipped over to the client is 1024 by 1024. So that's part of the pre-processing that I do on the back end, where I run ImageJ headlessly to do those sort of things before shipping it over here, because the transfer time, of course, is always a factor you want to keep in mind. The other main context that you might want to use ImageJ in, and actually before I do that, let me run this again just to show a tiny bit more of what ImageJ is capable of. Okay, and I'll brighten it back up. Okay, so this is sort of what I think of like a heavyweight previewing tool, because you can actually do little selections. You've got all sorts of, a lot of these are sort of scientific imaging types of tools. You can do the basics. You can deal with thresholds, all sorts of useful stuff. May be of use to you depending on what you're doing. Okay, let me show now the other main context that you would use. VG on. I'll go back, and that would be to look at output images. For that, let me actually get to a job that would have some output projections, or output images. I believe that this one here would. Okay, so we have 3 job versions, and I believe this one has it. My tooltips still aren't working. But as I launch it, it's going to do the same thing, but there's only going to be one image stack that gets created. And the message tells me that it's made and opening. And here it is. So as we scroll through these, it appears that some of them are blank for some reason, but you can see here we're sort of flying through it from like the top down of those cylindrically shaped objects. Okay, and let us take a look at some of these other views briefly. We can view all jobs by date. All columns are sortable. We also have paging going on, so as this list grows, this should scale up nicely because it's only going to show, or it's only going to retrieve a certain number of records from the database so as to get you something to look at right away, and then you could go next and previous, that sort of thing, to view all of them. Right now there's only 4 in this demo, so it's there's no actual paging to be done. I could view just by the group, which you briefly saw earlier, and then I could view ones that are just in that group. These are just different organizational ways of doing it. Editing and deleting of all of these levels of abstraction are fully supported. So we could go in and edit this, and that change has been made here. Okay, and lastly, I will, actually second to last, what I'm going to do is delete all the stuff I just did. And I'm doing it at the highest level of abstraction, so this is going to delete all of the jobs and job versions that are underneath the tests job group. So what it's doing at the database level is propagating those deletes outward. Again, I talked before about having those identifying relationships. So there are different schools of thought for this. I'll go ahead and do it. And you'll see. Different schools of thought. CakePHP provides a way to propagate those deletes outward at the model level. You can also do it at the database level. MySQL has those on delete cascade and triggers of that nature. I'm not sure actually which is the best way at all times. I actually did it at the model level with my design. I just liked the idea of being able to swap out the database without doing, you know, a whole lot of configuration of new triggers. Okay, and lastly, for a help mechanism, I have been shooting a series of screencasts that will be helpful both for a user of the application as well as follow-up developers. Again, this gets back to me wanting to build an architectural foundation that somebody else can just come in after me and build version 2.0. So I have a series of instructional things. Here's one on cake transactions. And the list is growing, including the one that I'm shooting right now. So in summary, and to recap, I've built a database-backed web application that utilizes model view controller architecture. I've strived to achieve an intuitive user interface that will lessen human error in this process, and I've strived to incorporate useful tools to make the entire workflow that Dr. Gregor was doing a single cohesive unit. So unlike a live presentation, I can't ask for questions right now, but if you do have questions or would like some follow-up, please feel free to contact me, and I'd like to hear from you. Thanks again for watching. I'm Jason Frank.